Good morning, my dear friends. How are you? Today, we will take a topic of perception. As you might have seen in my previous lectures, and I told you a number of times that perception is one of a very important cognitive process. Without perception, we can't think, we can't imagine, we can't, talk about, we can't tell what is happening. So, basically, what is perception? Perception is that when you are giving a meaning to a stimulus, it is called perception. What perception you are making, it depends on the type of stimulus, it depends on you, we will talk about attitude, etc. in this lecture also. It depends on these factors. So, when a stimulus comes before me, any stimulus, we have 5 sensory organs. It may be visual, it may be auditory, tactual, or any olfactory. Then when this sensory organ is stimulated, message goes to the brain, and brain tells us that what is that, and we give a meaning. It is a table, it is a chair, it is a eatable object, it is a ball, it is a bat, it is that, it is that. So, this is called as the perception. In perception, we have talked about illusion, we have talked about principle of perceptual organization, that how different stimuli are organized by the individual. We talked about the illusion. Illusion, I told you in my earlier lecture, is the false perception. When there is no stimulus, and when there is a stimulus is there, but we are making it an incorrect perception. A rope is lying, we looking to the rope, we say it is a snake, it is illusion. And we talked about number of illusions, geometric illusion, Muller-Lyer, then so many illusions I have talked about. Then I made a difference between illusion and hallucination. Illusion is, is the false perception in the presence of stimuli, whereas hallucination is again a false perception, but in the absence of the stimuli. Now, it is again number of types. In my previous lecture, I talked about the perception of depth. Perception of depth means the three-dimensional perception. Today, we will talk about perception of distance and movement. Now, if you see perception of distance, it is again a three-dimensional, or perception of distance and depth is almost the same factors operate in it. Now, we will see that what is perception of distance and what is the perception of the movement. Now, let us start today's lecture. The images cast on the retina are two-dimensional. When you see anything on the two-dimensional image is formed on your retina, and they preserve the correct spatial relations among parts of the visual field. The identification of the right and the left and up and the down are matters of relative judgment made possible by this correct preservation of spatial relationship. But we see objects as far and near, solid as well as flat. It is a near, it is a far away, it is a solid, it is a flat, it is stable, it is a flat. If you give me a water bottle, I will say it is not flat, clear, it is a solid. You take a piece of iron rod, it is a solid. But we see objects as far as near, solid as well as object. The question at once arises as to how two-dimensional retinal image lead to the perception of space in the depth. Again, I have told you depth and the distance is the almost same thing. Now, how this two-dimensional is converted into three-dimensional? It seems as if the perceiver uses certain clues and indications provided by these two-dimensional images to infer or construct a tri-dimensional space. So, on the basis of this two-dimensional, we infer, we just estimate this is the third dimension, or we perceive that this is the height, this is the depth, this is the width. We must emphasize the phrase as if. There is no reason to believe that any process akin to logical inferences take place. Tridimensionality is immediately given. So, when you look at the two-dimensional retina image is formed on the retina, it is converted into the three-dimensional process. Now, how this third dimension is perceived? So, what are the cues in the perception of distance? The cues responsible for perception of distance can be divided into two parts: monocular cues and the binocular cues. Now, you just go to my previous lecture when he talked about the perception of the depth. In perception of depth, we talk about in detail the monocular and the binocular cues. I still you must be recalling that I even with a figure I illustrated that. Now, monocular cues mean mono means one, single. If one eye is used, the cues from the one eye is used, it is called monocular. Bino, two. If both eyes are used, it is called binocular. So, monocular cues are linear perspective, relative size, interposition, aerial perspective, texture gradient, motion parallax and accommodation. I have explained all these in details. Binocular, the binocular cues are convergence, number one, and the binocular disparity. Monocular as well as binocular cues have already been explained, as I am telling you again and again, with suitable examples in my previous video on the depth perception. So, without devoting time on the perception of distance, we will directly shift to the perception of the movement, because perception of depth we have already done in the form of the perception of distance, we have already done in the form of perception of depth. So, now perception of movement. The space in which we move contains a variety of moving objects. People walking on the streets, cars speeding along the highway, birds flying in the air and so on. The perception of movement then is part of the objects in space. Many conditions determining the perception of stationary objects are also operative in the perception of movement. You see, if you go to your daily life, number of times daily, 1,000, million, infinity times we see that people are walking on the road, they are running, the birds are flying, the aeroplane is flying, clear. So many things on the highway, number of speeds with the high speed, the trucks, the bikes, the motor cars, they are running. This movement is perceived because they are in the movement. When a bowler starts running from his place to ball, we see that he is running, there is an actual movement. Now, but many conditions, I am reading last line again, I am reading again for the purpose. Many conditions determining the perception of stationary objects are also operative in the perception of movement. When the stimulus is stationary, the stimulus is not in the movement, this table is stationary, it is not running. When stimulus is stationary, still we are perceiving the movement, that is the important. You might have seen on the wedding, on the Diwali or any festival, you have lights on your rooftop and it appears that lights are running, where the lights are not running, the lights are stationary. This is the point, that when the object is stationary but still we perceive the movement, this we will talk about. So, the perception of a moving stimulus, first of all, thresholds of perceived movement. As in the case of other perceptual phenomena, there is a threshold which must be reached before a moving stimulus is seen as moving. First of all, the physical movement must attain a certain minimum velocity in order to be detected. So, there is no minimum velocity which can be specified as a threshold for the perception of movement. Now, here a word threshold is coming. What is threshold? Threshold basically, it is called, is a term came from the German Lyman, and it is called absolute Lyman, differential Lyman. Term is usually used in the psychophysics, which we will talk about in the other semesters. Threshold is the minimum amount of stimulus which provokes sensation. The minimum amount of stimulus which provokes sensation in the individual is called as the threshold. So, that is why sometimes we say threshold is the boundary beyond which on one side there is a one type of behavior and on the other side there is the other type of the behavior. For example, in a glass of water, you put just one particle of sugar and you ask me, sir, this water is sweeter? I will say no. Then you put the second particle, I say no. third, fourth, fifth, you are adding little bit sugar. A point will come where I will say this water is sweeter. Now, what is the minimum amount of sugar that provoked sensation of sweetness in me is called threshold. So, on one side I was saying, what I was saying, no, 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 no. Now I say it is sweeter, yes. Now the demarcating line is called as the threshold, and this threshold will vary for every individual, from one person to the other person. Similarly, for the perception of moving stimulus which are moving, there must be certain threshold velocity where you can perceive the movement. Now suppose one person walks, he moves one step very slowly. He has gone one step very slowly, the movement is there, but I am not able to perceive the movement. Now his increases speed 1, 2, 3, then I said no, he starts moving. Now what is that velocity where I have perceived the movement is called as the threshold. So I think the term threshold is clear. So when you are talking perception of moving stimulus, a threshold is required. The effect of distance. The farther away an object is, the more slowly does its image move across the retina. As it is so farther away, the image on the retina will be affected. If we assume constant physical velocity there are through which the retinal image moves in a unit time becomes smaller and smaller as the movement occurs at a greater and greater distance, we would expect that then that the object would appear to move more and more, will start more and more. So it depends upon the distance. If the distance is very farther away, it is at a larger distance, then the perception of movement will be different. But if it is nearer, the perception of distance will be different. Now you might have seen, if you look at the cricket match, you are sitting in the stadium on the top of the bench. Now all players looking very small, and when they start running, the actual speed you are not able to perceive. But if you are standing on the boundary line, then you can see the actual movement, because it is the effect of the distance. So the movement of the objects which are actually moving will depend upon the distance and your threshold. Now apparent movement in the absence of physical movement. Now the movement where there is no movement, this is called as the apparent movement. That means object is stationary, but still we are perceiving the movement. How is physical movement translated into stimulation that given rise to perceived movement? The answer to this question is by no means known, but it is clear that moving objects successively stimulates discrete adjacent receptors in the retina. The distribution of these receptors is punctiform. They are separated from each other by tiny spaces and a continuously moving stimulation. The perception of movement on the basis of discrete stimulation of different parts of the retina is even more potentially illustrated by the phenomena so called apparent movement. Of course, all perceived movement is apparent too, but this phrase has been reserved for those special cases in which stimulus objects remain stationary and the movement is perceived. Whenever there is your retina is perceiving some movement, the area of that retina is stimulated, but it is stimulating the adjacent part also where the image is not formed. But apparent movement term, we are using apparent movement even at that place also, but apparent movement term is used mainly when the objects remain stationary and still the movement is perceived. Now optimal movement and phi. Now this is a phi phenomenon we talk about. When two discrete stimuli, for example two rods of light, are presented in rapid succession, one of several types of apparent movement may be perceived. Which kind of movement is seen depends upon a variety of factors, among which the following are most important. You see, if there are two bars are there, they are stationary, but they are presented in a rapid succession, one light second, one light second, 1 second, 1 second, then we perceive the movement. Now, there is no movement, but still we are perceiving the movement. This is the type of the apparent movement. Now, which kind of apparent movement is seen depends upon variety of factors. And what are those factors? Number one, the distance between the two stimuli. What is the distance between the two rods? Are they just one to each other or separate? More distance, more distance, more distance. So, the distance between the two stimuli, their intensity and the time of interval between the first and the second stimulus. What is the intensity of the light? What is the time period between the first and the second light? In order to illustrate various types of movement with a time interval of about 60 millisecond, there is what is called optimal movement. The left bar appears to jump over the right one. It is as thought the bar itself is moved. The left, it looks that left is jumping on the right. So, when it is jumping on the right, movement is perceived, whereas there is a no movement. Both the rods are stationary. At some times between 60 and 200 milliseconds, pure 5 movements is often perceived. If the time presentation between the two is 60, range is 60 and 200 millisecond, then a perception is assumed, and that is called as the phi movement. Now, you might have seen even in the movies, on the picture or screen there is no movement, even they are rapidly running and we are perceiving the movement. This is your perception of movement in the stationary objects. There the hero and the villain are fighting with each other. Where they are fighting? It is simply they are really running so fast, intensity, the speed, the exposure, succession. Now, how this movement is controlled, there is a law for that, and that law is called Cote's law of movement. It is a very important law, sometimes questions is asked on it. Cote's law of movement, the relationship among the three variables. What are those? I have just talked about time, intensity and the distance. Time, how much time the light is there. What is the intensity? Intensity you are setting, strength of the light. If I in a very crude manner, intensity 2 watt, 3 watt, 4 watt, 6 watt, 60 watt, 100 watt is the intensity, and the distance. So, the relationship among the three variables, time, intensity and distance, have been worked out and are known as Cote's law. So, relationship between which variables, which three, time, intensity and distance is called as the Cote's law. What is that? We will talk about. Number one, if the intensity is held constant, you are keeping the intensity, the strength constant. The time interval for optimal movement varies directly with the distance between the stimuli. Number two, if the time interval, if the time interval is held constant, first intensity was held constant, now we are keeping time interval constant. If the time interval is held constant, the distance of the optimal movement varies directly with the intensity. Now, we have kept intensity time constant, now we will keep the distance constant. So, if the distance between the stimuli is held constant, the intensity of the optimal movement varies inversely with the time interval. So, if you are keeping one thing constant, the relationship between the other two factors, that is affected and it affects your apparent movement. These are called as the Cote's law. Now, one of the apparent movement is called as stroboscopic movement. Now, what is stroboscopic movement? The kind of movement described above, the perception of movement without a moving stimulus, has also been termed as stroboscopic movement. When the object is stationary, we are still perceiving, it is called as the stroboscopic movement. Originally, this term was applied to movement that results when slightly different pictures are presented in quick succession. Slightly different pictures are presented in a quick succession, your movie, your television. So, the movement which you are perceiving in the picture hall, in the cinema, is your stroboscopy movement. The principle upon which the motion picture depends is the, I have seen the principle upon which the motion picture depends is the best example of the stroboscopic movement. How the pictures are moving, the best example of the stroboscopic movement. The apparent movement is brought about by the projection at a fairly rapid rate. The rate is very high, they are moving in a very rapid rate, about 24 frames per second. You know, frame means one rate. So, they are presenting 24 frames per second. In 1 second, 24 frames are moving of a series of still pictures are still. Each of these still presents a slightly different view of the individuals or objects, which is then seen as moving on the screen. Animated cartoons utilize the same principle. These animated cartoons, that means movie, you have seen they are using, you know, the same phenomenon, the same principle. So, 5 movement is there, stroboscopic movement is there, and stroboscopic movement I have given you example of the movies. Now, I will talk about some other different type of the movements also which occur when we are perceiving something. First, we will talk about after images of movements. Just as continued exposure to a stationary object relate in a visual after image, so continued perception of moving stimulus produces an after image of the movement. If we gaze at a waterfall for a period of time, say a minute or so, and then turn our regard to the bank on the opposite side. Bank means the side of the river. Bank on the opposite side, the side of the bank will appear to move upward, that is in the direction opposite to that waterfall. The after image of movement may be termed as negative because this is reversal of the direction of the movement. You see, after image, what is after image? You look at a stimulus, and then close your eyes. When you close your eyes for a moment, the stimulus is not before you, but still, you know, we see a vivid picture of the movement. It is called after image, and we do conduct experiments on the after images. Now, after image may be positive, the after image may be negative. Similarly, this is a stationary object, I am presenting a color stationary, but similarly in the movement this after image occurs. Now, if you are looking at a waterfall, I have given example, waterfall, that is the movement, actual movement, and then you see, close your eyes and look at the other side, you see sometime it appears that something is moving. If it is moving in the opposite direction, it is a negative. If it is perceived in the same side, it is called as the positive. So, this is called movement after image movement, when stimulus is not moving, stimulus is not there, but still, you know, a vivid movement is perceived here. It is the example of the after image of the movement. So, we have talked about the after image of the movement. As I told you, just like the after image of a stationary object, it is after image of the movement. Now, we will talk about other type of the apparent movements. These two lights, so you see the two lights. An interesting phenomena of movement develops if the second flash is made considerably brighter than the first one. Under these conditions, the direction of the movement may be perceived. If the first light, you know, you flash means you are understanding intensity, we talked about the Curtis movement. So, flash is made considerably brighter if it is brighter than the first one. It's clear. Under these conditions, the direction of the movement may be perceived. I am saying may be perceived, not I am saying shall be perceived. If a dim flash on the left is followed by a bright flash on the right, the movement may be from right to left. Sometimes this is reversed, is followed immediately by a movement back to the position of the second and the brighter flash. This phenomena is a reversed movement due to the brightness. It is called delta movement. So, when the perception is due to the flash of the light and it is a reversed movement. This apparent movement is called as the delta movement. Now, one more type of apparent movement is worth mentioning, and that is very important, that is also worth mentioning. Only one stimulus object is required for its demonstration. Now, we will talk about the stimulus is only one, stationary, how the movement is perceived. If the illumination, that means light intensity of the visual field is suddenly increased. As suddenly increased means, as you know, for example, you have a fan 1, 2, 3, 4. Now, from 1 to just go to the full speed. Now, you are suddenly increasing the speed of the fan. So, if the illumination of the visual field is suddenly increased, the figure may be seen to expand at first and then to contract a stable size. So, if the intensity of the stimulus is suddenly increased, it appears there is a expansion in the stimulus and then it starts contracting. Similarly, if this bright illumination is suddenly decreased, the figure may be seen to be contracted. If you increase the intensity, expansion is perceived. If you decrease the intensity, contraction is perceived. So, this expansion and contraction of an object due to changes in the illumination is called as the gamma movement. The object is stationary, fine. So, because of the expansion intensity, brighter, less, expansion, contraction, this movement is called as the gamma movement. So, several other varieties of apparent movements have been reported in the psychological literature. As you have seen that the kinds of apparent movement depends upon the particular condition of the stimulus. I have told about condition of the stimulus. I have already explained you the importance of intensity, time interval and distance between the successive stimuli. Cote's law, I have just talked about the Cote's law, intensity, relationship between intensity, time interval and the distance. The size of the discrete stimuli and the length of the time during which each is exposed are examples are additional variables. These are additional variables in place of in addition to intensity, time and the distance. And what are those? They are length of the stimulus and the its time of the reporting. Now, equally important, now try to understand and listen carefully. Equally to this stimulus variable. Now, all these are stimulus variables, whether intensity or the brightness or the dimness, or the interval, they are all physical, they all are. Now, are some factors of individual also will affect this apparent movement? That is the point. So, equally important as this stimulus variable is the attitude that the observer adopts during the experiment. When we are conducting experiment on 5 phenomena stroboscopic, it is your attitude also which will affect. Uncritical attitude favors the apparent movement. When you are not critical, you are not analytic, we say it is moving, you say it is there is a movement. An analytic and critical approach may well detract for impressiveness of the phenomenon. If you are analytic, you will say how the stationary objects are moving. I tell you, Sheriff conducted an experiment in a dark room. He took two tube lights, that is a dark room. Now, this was the effect of the suggestion. Then the experimenter said to his subjects that lights are moving, lights are moving, lights are moving. The lights were not moving. The subjects also started perceiving that lights are moving. It is called autokinetic phenomenon. Now, this autokinetic phenomenon or the Sheriff's experiment, it is not on the stimulus value, it is on the individual. If they have analytic ability, then they will think through the mind that they are not moving. But if we are uncritical, we are suggestive, then we will come under the influence of the suggestion. So, attitude is also, personality is also important factor. So, we have talked about the perception of distance which is equal to the depth and the perception of the movement. This is all for today. Thank you very much.